Now we're going to look at undirected graphs, and undirected graphs are easy. We're just looking at, is something going in or out of it? Because there's no direction, we don't know, so we just look at the actual connections of edges in our vertex. I actually took the edge labels off of this just so that it's a little bit of a cleaner graph for us to go through. And I made a 4x4 grid here because we have 4 vertices, and then I made a 4x4 grid here on that one because of 4 vertices. Okay, so let's go ahead and take a look. I'm looking for loops first because that will fill my diagonal. There are no loops on V1. There's one loop on V2. There's no loops on V3, and there's one loop on V4. So I've got my loops taken care of. So now I'm going to look at V1, and I see that there's 2 connections in here. One comes from V4 and one comes from V2. So V2 and V4 are filled in, and then V3 is left at 0. Again, I'm going to take a look at V2. V2 has comes from V2, 2 from V3, 1 from V4, and 1 from V1. So 1 from V1, 1 from V2 itself, 2 from V3, and then 1 from V4. Now I'm going to look at vertex 3. Vertex 3 here has 2 connections. Both of those connections are coming from V2. So on vertex 3, V2 is that. And then I would have a 0 here and a 0 here. And then let's look at V4. And on V4, I see a loop, which I already have, and then 1 to V2 and 1 to V1. So V1 and V2 have 1 and nothing to V3. Now, one thing I do want to point out is you do have symmetry because these are both ins and outs. So if you look at your symmetry this direction, right? Actually, this is your line of symmetry. So if you look at what's on either side, like 0, 0, 1, 0, 1, 1, 2, 2, 1, 0, 1, 0, 1, 1, and 0. So that's where you have that symmetry. So if you want to check yourself, this is a really easy way to do that on these directed graphs. And then the last thing we got to do is go ahead and stick it into an actual matrix. So our adjacency matrix, I'm going to go ahead and write it out first. So 0, 1, 0, 1, 1, 1, 2, 1, 0, 2, 0, 0, and 1, 1, 0, 1. So this is my adjacency matrix for the undirected graph that's above. Let's take a look at this other one. And so this other one, what I'd love for you to do is go ahead and pause this video and see if you can do this one by yourself and then come back and check your work. All right, let's look at this one. We've got a loop at 2, so 2, 2 has a loop, and there's a loop at 3, so you've got 3, 3, and then nothing on 4 and nothing on 1. So I'm going to look at vertex 1. I have a connection to V2, a connection to V3, and a connection to V4, and it's just single ones, V2, V3, V4. Then I look at V2. I already have the loop taken care of. I have a connection to V1 and 2 to V4. So a connection to 1 and 2 to V4 and nothing connecting V3. Then I'm going to look at V3 and I see that I have a loop here, which I've already accounted for. And then I have a connection to 1 and I have a connection to 4. So a connection to 1 and a connection to 4 and then a 0 here. And then I look at my fourth one here, and I've got 2 connections to 2. Let's see here, I didn't mean to do that. So we have 2 connections to 2, 1 to 3, and 1 to 1. So we have 1 to 1, we have 2 to 2, and we have 1 to 3. All right, so again, I'm going to go ahead and test this. This is my line of symmetry. I should have 1, 1, 2, 1, 2, 1, 0, 0, 1, 1, 1, 1, 1, 1, and 0. So it looks like I'm in good shape on that one. So to draw my matrix, my adjacency matrix, is going to be 0, 1, 1, 1, 1, 1, 0, 2, 1, 0, 1, 1, and 1, 2, 1, 0. And all I'm doing is taking my table and putting it into brackets. That's all I'm doing. Okay? So that is a undirected graph examples. And then in the next video, we'll go ahead and take a look at this. And we're going to go straight to the matrix calculator to show you how to do that.